Hey guys, I'm here back in another math video. Today we're going to be doing AIME 2017 problem number 8, AIME 1 that is, and it's a geometry question, so pause the video if you need to, look at the question, and without further ado we're going to try to solve it. So the first thing we should do, of course, is try to draw this out. So here's point O, here's point P, maybe, and OP is 200. So, okay. Let Q and R be on the same side of line OP such that agreed members of POQ and POR are A and B respectively, and that OP, OQP, and ORP are both right angles. Okay? So let's just say that is Q. Let's say that's R. Alright. These are right angles. And so it says POQ is A and POR is B. So the diagram looks like, and one thing you should notice is that since OQP and OQR are both right angles, that this actually looks, I think we can draw a circle around this such that OP is the diameter, and Q and R lie on the circle. See if my circle drawing skills are intact. So yeah, there's our circle. Because these are right angles, OQRP are right angles, that means that and OQP are right angles, that means that we can just draw a circle around all of this with OP as the diameter, because that's a property that if you connect the diameter to any point on the circle, it'll form a right angle. So once you notice this, it's actually not too bad, but let's keep looking. So QR is less than 100. So let's try to find the maximum angle, let's try to find the maximum angle that will satisfy that QR is 100, and maybe this will help us out. And actually, I think we can do it. So in any cyclic quadrilateral, if you draw the diagonals, these angles are the same, and these angles are the same, and these angles are the same, and these angles are the same, which means that essentially a cyclic quadrilateral has a lot of triangular similarities. So like this triangle is similar to this triangle. So actually what we can do is that if we want this to be 100 and this to be 200, we just need to have this side be equal to half of this side by similar triangles. So what angles A and B will give us so that this side is equal to half of this side? Well, if this is A and this is B, then this angle is A minus B, right? And notice that this triangle right here is a right triangle. So let's call the center point, I don't know, QRS. We don't have an S. That means QS is, since we want this to be less than or equal to 100, QS will be less than or equal to 1/2 of OS by similar triangles. So if this is less than 1/2 of this, this will be less than 1/2 of this by similar triangles, because these two triangles are similar. So in order to do that, that means that A plus B has to be less than 30. Because if you think about it, QS over OS is equal to sine A minus B, which you know is less than 1/2. So sine A minus B is less than or equal to 1/2, which means that A minus B is less than 30. And Remember, Q and R can be switched in position so that B is the larger angle. So basically, if B is the larger angle, it's the same reflectively. So essentially, that means that just the difference between A and B has to be less than 30. And now that we have that, the question is substantially easier. We can just use geometric probability. And what geometric probability is that you sort of plot down the, let's just plot a graph of A and B. So A, B. And this is 75, this is 75. So this is the map of all possible values of A and B. How much of that map is filled up with successful values? So if you just try some values and like play around with this map, you'll actually figure out that like this is 30, this is 30, 30, 30. This will work. So any A and B value within this strip will satisfy the condition of A minus B is less than 30. For instance, like say right here, if A is 30, B can be anywhere from like 60 down, right? And let's say if you're right here and A is 45, B can be all the way from 75 down to 15, right? Because that means they're 30 away. So actually, this graph works really well. And from this graph, the way to derive this graph is literally just to plug in values of A and B and sort of like generate the shape yourself. But what this graph will give us is that we just have to divide the area of this graph over the area of this square to find the probability. So instead of finding the area of this strip, let's find the area of these blank spaces with side length 45. So the area of the unsuccessful space is 45 squared. And the area of total space is 75 squared. So the probability equals 1 minus 45 squared, 75 squared. That's going to be equal to 16 over 25. And if you add those together, because we want m plus n, the numerator and the denominator, we get 41. So that's the answer. I think this question was pretty enjoyable. It had a nice clean solution, and yeah. So I hope you guys did well on AIME. I know I didn't, but yeah. So see you next week. Intervals that do not intersect each other. And that's not going to be a very big concern because in this question none of the intervals will intersect each other. So what this question is asking is essentially, given x, my pen pressure is not working,